we are going to do is have a look at how to do ray diagrams for convex mirrors. And so you can see the convex mirror, it's just symbolic. So what we're really interested in is the set of axes that I've drawn there. We're not actually going to reflect light off the convex mirror, it's just there to symbolise what we're reflecting light off. And you can see that where the convex mirror touches our set of axes, that point there is called the pole. And that the horizontal one we call the principal axis, like the main axis. Thinking about what a convex mirror is, it's to make a convex mirror you make a big ball of glass and you cover the whole inside with reflecty stuff, and then from the centre of that ball you just cut little bits of mirror off. And so we can imagine that this convex mirror is part of a really big round circular mirror, and so the centre of the mirror really is like the centre of that original ball that we started with. What we call the focal point is exactly halfway to the centre from the pole. So the centre of the mirror really is the centre of the circular mirror. The focal point's halfway from the pole to the centre. And we're just going to draw on an object, kind of a symbolic object. And for that we're just going to use an arrow. An arrow is nice because it's got an orientation, like we can see that that's pointing upwards, and that's going to help us keep track of like which way up our object is compared to the image that's formed. And so there's three rules, for light reflecting off the convex mirror, what happens is the light goes in, hits the mirror, and the angle of incidence equals the angle of reflection. But that can get quite complicated to draw those diagrams, and so we've come up with like a simplified set of rules that if we follow, we can draw other rays that follow those rules, but we don't have to measure any angles, so it's really useful. So there's only ever three rays that we have to draw. Two rays to find an image, and then a third like a checking ray to make sure we've got it right. So the first ray, #1, we're going to go in parallel, that's parallel to the principal axis, out through the focus. And so let's have a look at what that might look like. We're going to use a ruler for these. I'm not going to use a ruler because it's just going to be complicated and take longer. So, in parallel, and you can see I've gone right through the mirror and I've gone back until I've hit that vertical axis, out through the focus. And so out through the focus. So the first ray we've drawn in parallel, out through focus. Noticing that we've got straight ruled lines for our rays and arrows to show the direction that the light's going in. Second rule is just the opposite. In through the focus, out parallel. And so we're going to line up the top of our object with the focal point and go right through until that ray hits the vertical axis out the back, and then out parallel with the principal axis. Straight ruled lines with arrows to show direction. Then the third ray goes in and out straight through the centre. It turns out that any ray that goes through the centre of the mirror hits the mirror exactly along the normal line, and so it reflects off without changing its angle at all. And then out straight through centre. So lining up the top of our object with the centre of the mirror, and that's going to go on down to some point down there where it crosses the mirror, and it's going to go on back that way. So notice that that third ray has got arrows going in both directions. That's because it reflects back and travels back along exactly the same path. And check it out. We've got a point where the red and the blue rays converged, and then our third ray that we drew checked and went through exactly that same point. So where those three rays converge, that is where the image is formed. And so we're going to draw an arrow to represent the image from the principal axis. But because those three rays are converging below the principal axis, that means that our arrow is going to be drawn upside down. And so that shows us that our image has been formed upside down, we say inverted. And so looking at this diagram here, we can see three things about our image. We can see that it's inverted. We can see that it's upside down. What can we see about the size of it?
Small.
Smaller. What's a physics word for smaller that starts with D? Diminished. And the third thing is that it's a real image. And we will learn to be able to see that from the diagram. What a real image is one that you can put a piece of paper there and the image will form on that piece of paper, much like if we use the projector and we pull down a screen, we can really see an image on the screen. That's a real image, you can really see it. There are other images that you can't put a piece of paper there and see on a piece of paper. So that one is a real image.